what I'm sharing here.
I can see.
Okay.
If everybody can see okay, please type into the chat or the Q&A pod. Thank you so much, everybody. All right, Jennifer.
Welcome this afternoon to the NASA Langley Atmospheric Science Data Centers demonstration of the first release of SOOT, the Sub-Orbital Order Tool. For those who may not be familiar with the ASDC, or the Atmospheric Science Data Center, also known as the ASDC, we are one of 12 NASA Distributed Active Archive Centers, or DACs. As you can see in this map, the DACs are located all throughout the United States, and each DAC specializes in specific subject matter. If we take a closer look on the East Coast, we see that the ASDC is located in Hampton, Virginia, at NASA Langley Research Center. As its name implies, the ASDC specialization is in atmospheric science and meteorology data, derived not only from satellite measurements, but also from modeled data products and suborbital campaigns. Within the larger specialization area of atmospheric science and meteorology data, the ASDC focuses on 4 main research areas listed here: radiation budget, clouds, aerosols, and tropospheric composition. At the ASDC, we ingest, process, archive, and distribute data from satellite missions and suborbital campaigns that relate to these 4 areas. In 2020, we in turn provided users in 158 countries access to more than 1,100 archive science products. Last year alone, the ASDC distributed over 2,500 terabytes of data to more than 160,000 customers. As mentioned, the ASDC is assigned missions and projects that relate to the 4 study areas. While we support many missions, a few of them are more well-known. Our first study area, aerosols, or tiny particles suspended in the air such as dust, pollen, and industrial emissions, can be investigated using ASDC data, for example, from the instrument MISR on the Terra satellite. Secondly, the ASDC archives data in the study area of cloud properties, such as cloud top temperature, that are studied by satellite instruments like Calypso. The third study area is that of tropospheric composition, or parameters such as nitrogen dioxide, ozone surface mixing ratios, carbon monoxide, and particulate matter as measured by the MOPIT mission, for example. The fourth study area is the Earth's radiation budget, or the amount of incoming shortwave radiation from the Sun versus the outgoing long-wave radiation from the Earth, which, for example, can be explored through the instrument series. The data examples I have just mentioned all came from satellite instruments that you may be familiar with. While satellite data constitutes much of the ASDC's data holdings, the ASDC archives a plethora of suborbital data related to the 4 study areas as well. A few examples of airborne and field campaigns at the ASDC include these 8 missions that are contained in the SOOT tool's first release, with many more to come: Listos, ACEPOL, FireX-AQ, Camp 2EX, Arise, Oracles, Elmos, and Names. Since we are focusing on a suborbital order tool today, it helps to understand a bit about suborbital data. It is derived from airborne and field campaigns that make observations about the atmosphere using multiple measurement platforms, including aircraft, ships, ground stations, mobile laboratories, drones, sondes, or sometimes even including satellites as a means for validation. Together, these platforms form integrated observing systems that collect measurements of many variables. Suborbital data is also often used for validation of satellite missions as well. NAMES is a campaign that's a great example of the complexities involved in utilizing a combination of ship-based, airborne, autonomous sensors like SONs, and even remote sensing measurements to make observations about relationships between aerosols, clouds, and the climate in a marine context. Because of that, we will use names for many of our demonstrations today. Now that you have had an overview of the types of data that the ASDC holds and a general overview of the suborbital data, this presentation will provide an introduction to the SOOT tool and explain what SOOT is, why it is needed, who it serves, and a demonstration of how it works. We are eager to answer your questions following this demonstration. SOOT is a framework for handling data acquired from suborbital field campaigns that currently are assigned to and archived at the ASDC. Its customized database streamlines data ingest and metadata parsing to provide data discovery and accessibility for ASDC end users. We are in the beginning discussions with other DACs who have expressed an interest in including their suborbital data as well, so keep your eyes on future releases. In comparison with satellite data community, for which many order tools are designed, the suborbital data user community has very different requirements due to the unique nature of their data. For those who are familiar with suborbital data, you will already be aware of the many ways in which airborne and field data differ from satellite. There are often many organizations, a variety of platforms, plethora of instruments, and sundry principal investigators involved. The standard tools created to allow users to search satellite data are not designed to handle the multitude and kind of variables that these campaigns generate. This brings us back to our purpose for being here today. SOOT was developed for this purpose. Currently, the tool is in its first version release with a modern interface to employ detailed metadata records to help promote accurate search, discovery, and data access capabilities for our ASDC suborbital data users that have varying expertise. This tool is in ongoing development with many additional features to be unveiled in future releases. In addition to the unique needs of suborbital data, NASA and ESDS have issued directives expressing the need to separate field repositories and data archiving and distribution functionality at DACs. Currently, services like the DubAir field repository sometimes fill both capacities. To address these needs, the ASDC is working closely with DubAir managers to streamline functionality into SOOT. For clarity, DubAir will continue to be the field repository for scientists. However, once the data has been finalized and of publication quality, it will be archived at the ASDC and available to the public through SOOT. Names will be the first project to complete this process and be deprecated from access on DubAir. SOOT is designed to grow incrementally, providing different user interface environments to meet the needs of users with varying levels of expertise. The Power User interface is included in the first release of this tool. It is intended for experienced suborbital data users and science teams. This interface allows subject matter experts to quickly navigate to a particular instrument, PI, and the correlating data files needed for their analysis. Planned for a following release is the General User interface, which is intended for users with minimal experience using airborne and field campaign data. This interface will feature faceted and variable search functionalities, as well as flight track mapping. Like many tools, SOOT will also include an API interface for experienced users wishing to download data who have no need to filter or search. Set for our next release, though, we are currently working on a highly requested temporal alignment feature referenced as merge in the airborne world. This will allow users to compare and analyze multiple files within SOOT. This presentation will focus on the Power User Interface, which caters to suborbital data experts and currently is available in its initial released version. As mentioned previously, the merge feature and other user environments will follow in successive releases. So let's dive into the Sub-Orbital Order Tool. As soon as it opens. There we go. Let me first introduce you to the home page of the Power User Interface. While these 8 missions are currently included in the tool's first version, all airborne and field missions at the ASDC will be integrated into the tool. As the other environments, such as General User Interface and API, are released, they will be accessible at the top here to the right. Notice each mission's card provides entry to the data and access to available support documentation. Some missions had a single campaign, like ACEPOL, while others, like names and oracles, have had many. Because instruments and participants in the mission can vary between campaigns, suborbital data is presented by year as the overarching category. Let's start with a relatively simple search. We begin as an experienced user who wants to download data from the Listos mission from a specific date. Let's say May 17th, 2017. Clicking 2017 opens the next page to reveal the mission abstract and access to the data. As you see, this campaign only has one platform, but it does have data from multiple dates. We could select all the dates, or we can deselect by clicking none. But we really only want data from the 17th. So let's choose May 17th. At this point, you'll notice in the Review Selected Files button, there is an overview of the number of files that we have selected, as well as the volume of the download. Clicking the Download button packages our files for download. You will notice that the user is asked to use the Earth Data login to access the actual download. This login is used by many NASA tools and services to provide a single sign-on for the user and data use metrics for NASA. So let me sign in quickly here. After signing in, we're returned to the final page where we download our zip file, which you will notice is prepended with the name of the tool, SOOT, the name of the mission, Listos, and today's date, so that we can find this file easy at a later time. Let's return to the home page now and take a look at the options along this discovery path in more detail. This time, we'll explore the names mission. Let's choose the 2016 campaign. And this time, we notice that there are a number of platforms available. Experienced researchers will recognize Atlantis as a research vessel, though we've added a ship icon as a hint, and the C-130 is a plane with its appropriate icon. Data from other sources, such as trajectory and analysis, are included here, despite not originating from an actual platform. However, this provides easy access to the multiple types of data and is a familiar format for those transitioning from a field repository. You may also notice the merged data listed here. This set of data is canned, meaning that the files are being merged or aligned temporally. They've already been pre-selected in advance. As was previously mentioned, a separate feature that will allow the user to make their very own selections of files for comparison analysis will be offered in a future release. For this demonstration, we will explore the data collected by the C-130 plane. These first three sections, Year, Platform, and Principle Investigator, or PI, filter the files for easier viewing, but do not select the data. Choosing the campaign provides access to the platforms that are involved in that deployment. Choosing a platform provides access to the principal investigators who were involved in that deployment on that platform. Choosing a principal investigator, for instance, Brian Carnes, will then show the data IDs he was involved with in the next section. Notice, since the right side continues to allow you access to view all of the data available, the selected files for that particular PI are brought to the top for easy access. Now let's look at the last two sections, Data ID and Start Dates. These allow users to actually select files in bulk, while the view to the right allows users to select individual files for download. For those unfamiliar with the term Data ID, the use of Collection ID is a similar concept in the satellite world. A data ID includes a short description of measured parameters, species, instrument, or model. For instance, Brian Carnes' data ID here indicates that this data was generated by the Research Scanning Polarimeter Instrument, or RSP, and it was used to measure cloud properties. By checking a box here in Data ID, you will notice that all of the files on the right that are part of this grouping are automatically selected. In this case, there are 281 files in that particular data ID. And maybe this is not what we wanted. So we can easily, again, in bulk, deselect by clicking None. In the last section, the Start Dates operates separately from the Data ID section. This functionality allows a user to select all data from a given day across all the PIs within a given platform. By selecting a date, all the relevant data files for that day are selected on the right, and you can see the date in the title of the file. As in the section above, we can easily unselect individual files or deselect the files in bulk by clicking None. The feature also exists if we wish to start over, to always at any time click the Clear All Selected Files. Let's now take a look at Bruce Anderson's data for a moment. In the data selection section, you will notice that many of these selections have a variable link. This provides a cursory look at the variables mentioned. For instance, in the aerosol mass spectrometer data ID, we find an overview of the variables that this instrument measures. Suborbital experts using the tool have indicated the importance in displaying the variables here in the exact order as they appear in the iCart file. And so this is the default display. However, we have added sorting options at the top of each column to offer flexibility to sort alphabetically by variable name, units, or description as well. Let's now look at Bruce Anderson's C-130 data files for the Cloud Droplet Probe, or CDP. Notice that I now have 11 files in my shopping cart by choosing that data ID, and that by selecting this button, we can quickly review all the data, and we now have the ability to make final changes before downloading. Since the date is included in the file name, I can tell that all of this data covers the dates from May 13th through June 3rd. I decide that I really only want to include data from the week of May 15th, let's say. So I'm going to remove anything except for the 18th, 19th, and 20th. I now am left with 3 selected files. Now, before I go to download, tool users also requested the ability to be able to select files from more than one mission in the exact same download. So to demonstrate this, let's add a second mission's files to our current selection before we download. So we'll cancel to go back. Go back to the main page to choose another mission. And we notice down here in the bottom that the 3 files I selected still remain. I did not lose them. This time, let's choose another mission. Again, we'll choose Listos, 2017, the aircraft platform. And this time, I'm going to choose this top data ID. Notice this particular grouping only has information from the 17th and 18th, which fits into the week I was currently looking at. On the right, I have now selected 3 additional files from the same time of year that I can now analyze with my other 3. When I click Review and Download, we will have those files prepared into a zip file again. When I click Download, notice that the files this time is prepended with 2 mission names since we included 2 different missions in this. Once the file is unzipped, however, you look down here to the bottom, you can see that the initial original titles of the files, of course, remain unchanged. Now, I've got all the data files that I want. Now I want to look at any supporting documents to find out what else is available about these data sets. I'm going to again return to the home page, where each mission has a link to its related supporting documentation, as I pointed out at the beginning. So, clicking this link takes us to the mission's landing page on the ASDC site, where all documentation is displayed. Because some missions have very lengthy lists of supporting documentation, we've provided the user with the ability to collapse and expand all or parts of the listing for easy use. Additionally, this drops the researcher at a very valuable spot on the ASDC site. The individual can do more in-depth research about the mission, including details needed for publication level research. Now, learning a new tool is like going to a new grocery store. It may have all the same choices, but in different aisles. To help users adjust from finding their data in a field repository, we took a step beyond the tool. In preparing for releasing SOOT to the public, we created an online resource in the form of an ArcGIS story map, which is a method for demonstrating a user's journey and more naturally mimicking a user's experience of the online tool. We developed this resource to both announce the tool's release and to educate interested users about the new tool's abilities. We will continue to provide additional tutorials and updates on user environments as the tool continues to develop. Currently, you will see we have included information about the Power User Interface that we have already viewed today. Additionally, included in the feature highlights are some quick tutorials to help users get started. Additional tutorials and other versions in development, such as merge capability, general user interface, and access to the API, will be added to this story map as these functionalities complete testing and are released. While we realize that not all are familiar with suborbital data, we thank you for taking time to learn about this available resource. We hope you will take some time to explore the tool as it grows in capabilities and provide us with your questions and feedback in the link up at the top. If you found this interesting and would like to participate in providing feedback in future user testing, please provide your email address in the post survey. With that, I'll give the presenter role back to Jennifer Brennan for the final polling questions and to address any questions you may have. Thank you very much.